extremely buoyant material. So when these two come into contact with one another, which of these two is going to take the deep sinks? The continental or the oceanic crust is going under, and again, the same thing happens here. It begins to melt. As it melts, it begins to form lava or magma. Magma rises to the surface, melting existing materials, and we end up with, again, a whole series of volcanic peaks. The Andes Mountains are a prime example. The Cascade Mountains of North America, another prime example of oceanic crust coming in contact with continental materials. Again, we go back to the diagram in the book. Here we have a convergent zone, and again, the trench is on this side. We have the Andes here. We have a series of mountains in the Isthmus of Central America, up in this region again, and all of these are due to continental crust and oceanic. The type of volcanic peaks here are different than we find in the island arc. These are a combination of granite and mafic materials. Island arcs are all mafic materials. Okay, so that's two. What would be a third option? Okay. Third option would be continental crust coming in contact with continental crust. So you have continental crust here, you have continental crust there. You have, again, felsic materials in both cases. Felsic materials are buoyant. Neither one wants to go under. And so what happens, they collide, they hit, and literally, as they come in contact with one another, one of these is going to ripple and form upland areas. Look at a car fender hitting another car fender. Things will be reduced in scope this way, but you end up with ripples, and this is what happened with India. Here's India colliding with Asia, and the Himalayan mountains result. Remember, we followed India through this path. Here it is over here. There's a convergence zone. And again, Himalayan mountains, the Tibetan Plateau. Whenever continental crust comes in contact with other continental crust, very violent upheaval of the land surface. Violent volcanic activity. Okay, here we have a big block of continental crust, hundreds of miles wide. What would happen if we compress this to about half its length? What would happen to the surface? Okay, what would happen to the surface, of course, is you may end up with a mountain system, but the mountain system has to be supported. Some of the crust is going to go down, some of it will go up. Mountain systems such as the Appalachians would be formed because of this activity. The Andes formed because of not the Andes, the Himalayas formed because of this. But on a smaller scale, what happens occasionally, if the process is slower, we can compress the land surface into a series of nice rolling ridges and lowland areas. Remember, the forces are this way, convergent plate forces. We're compressing the land surface. We're taking the land and we're doing this. literally forming a series of ridges and valleys as we go through. The Appalachian system is a series of ridges and valleys. And they formed prior to 225 million years ago.
5 minutes.
5 minutes, thank you. The reason they formed at that time, Africa collided with North America. Remember, this is prior to Pangea. Africa collided with North America. The Appalachians formed here. What are the mountains in northwest Africa? The Atlas Mountains. They all formed at the same time. So again, these two landmasses push together very gently. We end up with features of this nature. These are, this is referred to as folding activity. The rock units are displaced but not fractured. The rock units literally bend with the pressures that we have. The high points here are referred to as anticlines. The low points are referred to as synclines. And that's what our Appalachian system is, how it formed. The Blue Ridge. All of that area is a series of anticlines and synclines. And with that happy note, I think we covered everything that's on the quiz. See you on Thursday. Brian, was that slower? Just be